Good thing I had my helmet on. Which brings up an interesting question. I mean, how can we really be sure that something like a bike helmet's gonna protect our noggin? It's not like I want to test it for myself. But you know, there are people that do just that. They strap on bike helmets, then ram their heads into solid steel. Who is this crazy bunch?
Well, they're the Canadian Standards Association, an international organization that tests the performance, quality, and safety of many of the products we use every day. You can find their mark on more than 1 billion products, everything from sewer pipes to sewing machines.
So how do you make sure a product's going to perform properly and safely? Well, the CSA has devised a number of ingenious little tests to simulate a lifetime of use and abuse.
For example, there's the endurance test. Here, a product is operated over and over again under the same stressful conditions it would experience out in the real world. These electrical switches will have to turn on the same light bulb 30,000 times. This faucet will be mechanically turned on and off 500,000 times to simulate years of service. After the test, the faucet will be examined. If there's any abnormal wear and tear, it's back to the drawing board. But in many cases, a product's performance is directly related to safety. Take a bicycle helmet, for example. Its primary function is to protect your head from injury. Now, to see if it will actually do the job, it's put through an impact test. The helmet is strapped onto a dummy head that simulates the shape and weight of a real person's head. The helmet is then raised to a predetermined height, then dropped onto a solid steel plate. A computer measures how much the helmet gives. This one passed. This hockey face mask is about to receive a 100 km/h slap shot, courtesy of this high-powered air cannon. Nothing more than a dent and a scratch. They use the same method to test safety glasses, but instead of firing pucks, they fire solid steel ball bearings.
Now, firing ball bearings at safety glasses is a pretty effective way of finding out whether they're going to protect your eyes or not. But not all tests are that straightforward. You see, with some products, you need to simulate a number of different scenarios.
This lawnmower is going to be tested for its short circuit potential after it's been left in the rain room for a while. Sometimes they get really tough. This fan, for example, will have to operate for 18 days with its rotor jammed without causing a fire hazard. This vacuum cleaner not only has its rotor jammed, but it's covered in case yours jams while under the curtains.
But to really put a product through its paces, you need to see how it performs out in the cruel world. But how do you do that without going outdoors? How about bringing the great outdoors indoors? And that's just what they do with these.
They're environment chambers. There's the Sahara room, which is hot and dry. It can get up to 50 degrees Celsius in here. There's the tropical room, which is hot but humid, up to 90% humidity. And then there's the Arctic chamber, which is, well, really cold. They can bring this room down to minus 40 degrees Celsius. They're testing a television picture tube right now. They'll leave it in here for 4 hours, then bring it out to room temperature for 4 hours. They're simulating the kind of temperature fluctuations the tubes experience during shipping. They want to see how the metal and glass contract and expand as a result of the temperature changes. Too much expansion and contraction can cause the tube to crack. The Canadian Standards Association, testing the performance, quality, and safety of many of the products we use every day.
Boy, I hope they test environment chambers, too. Hello? I think I accidentally locked myself in here. It's getting kind of cold.